Hi. So you might be wondering, where's Mr. Dramus? What is this? This is blasphemy. Well, I'll show you that in a minute. Because when the Mad Titan is tired, you don't really try to rock the boat with going upstairs and going on a light board, right? So we just want to keep him calm, right? Because he has no remorse when he starts to destroy stuff if I go upstairs. So I'm gonna make a couple of quick videos for you in this format, this fashion, and you can see him at the end of it and you can see what I mean. Okay, so Half-Life Part 2, right? The formula is y equals A, and A stands for the initial amount, meaning the initial amount in grams or whatever else I would give you in terms of the element. So basically there's an element and I give you how much that element is or how much there is, that's what A is. Half-life is easy because the common ratio is always 0.5, right? The rate of decay is always 50%, like half-life, okay? T is the exponent, which stands for cycles. Now, cycles is calculated by a fraction. It's the total time that elapses in the problem, meaning the problem's always gonna ask you how much is left after a certain time period. That's the numerator of that fraction. The denominator is, well, what is the actual half-life of that element? So let's just go ahead and do a couple of examples to see what we mean. Right? So let's say that I have titanium, get it? Okay. Now, let's say I have titanium 98. When there's a dash there in between the element and a number, that number has nothing to do with this problem. That's scientific, that's part of the element, that's how that element is differentiated between titanium 97 or titanium 16, for example, okay? So this number that's right next to titanium, or whatever the number is right next to the element, does not matter in this problem at all, okay? So don't try to plug that in anywhere. And let's say the actual half-life of titanium 98 is 7 hours, meaning every 7 hours, half of it is going to go away. Let's say that I have 100 grams of that element, okay? I wanna know how much is left over after 28 hours. Okay, now here's what we've got here. We know that we have 100 grams of starting amount of that element. The half-life is 0.5. Now T is going to be total time that passes in the problem divided by the actual half-life of that element. And it's gonna give us a nice even number of 4, and that's what's gonna be put into the calculator. You're gonna put that in the calculator exactly how it shows it. Now, you're gonna put that in the calculator, and I'm gonna step away, and I'm gonna get my calculator because I left it in my book bag. Hopefully, the Mad Titan stays laying down. Okay. So hopefully you've got this taken care of. 100, 0.5, fourth power. Okay, so hopefully you can see that. Yep. Okay. Boom. 6.25 grams. That's how much is left over. Now, I can do this the long way so you can get a little bit more context here. We started with 100. One half-life goes away. That means 50's left. That's one half-life's worth of decay. Another half-life gives me 25. So after 2 half-lives, it gets to 25. 12.5 would be the next half-life. And then the fourth half-life, which is what we wanted, gives us 6.25 left over. Okay, so that's how this is. That's how this works, guys. Okay, let's do another example. And oh god, he's up. I know. Go lay down, buddy. I have to do this quickly. Dramesium, the most important element of all time. Let's say it's dramesium 4. Let's say there's 200 grams of it. Oh, you can't see. Sorry. Let's say its half-life is 100 years. It's just impossible to get rid of. Okay. Let's say I want to know how much is left over in 25 years. So there's a problem here, right? It's not really a problem, but it's just weird. The half-life is bigger or longer than the amount of time that goes by. Well, we're still going to use our little fraction here, right? The total time that goes by in the problem is 25 years in this one. But the actual half-life of the element is 100. So this is going to get to be 1/4, or if you want to make this a little bit easier to put in the calculator, you're going to do 0.25. All right, so that's T, that's cycles, okay? So I'm going to go 200 times the quantity of 0.5. I'm going to raise that to the 0.25 power, meaning I'm only going through a quarter of a half-life. I haven't even gone through one full half-life yet. So this one's going to be important to put in the calculator the right way. So 200, 0.5. We're going to raise it to the 0.25 power. And it's going to give me that nonsense. Now, unless I say to round, which I probably won't, just write the whole thing out. Okay, so that's how much is left after 0.25 of a half-life. Hope you enjoyed this video. And that's what he's doing right now. Hey! What are you doing? Please don't do that. Please don't do that. Lay down. Oh my gosh, please lay down. Yes. That's a good boy. Thank you. No. Just lay down. Good boy. Whew. I might be able to get a couple of videos done. See ya.